Graphing quadratics. A quadratic is an equation that has an x variable raised to the second power, like you see here. This is the most basic form of a quadratic. And let's just see how this original, most basic graph would look if we plotted the points that made this equation true. So I'm going to go with, I'm going to look at -2, -1, 0, 1, and 2. When I plug in -2, I have to square it, so I get a +4. When I plug in -1, -1 squared, or -1 times -1, is +1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. The reason I'm squaring each one is because I'm plugging into that spot for x. I'm taking each number and plugging it in. When I plot these points, I get, here's 0, 0, here's 1, 1, and here's 2, 4, and here's -1, 1, and -2, 4. And I could even see, I could even do 2 more. Let's do 3 and -3. I would get 9 for both of those. So it'll be here and here. So when I draw in the nice smooth curve, it looks like this. And here I have all my values plugged in. Now, like I said, this is the most basic form of a quadratic. But I can always multiply that x squared by something. I can subtract something or add something to the x. And I can add something at the very end to the entire thing. And that's what you see in this equation down here. This is called vertex form. Each one of these variables has an effect on this original graph of x squared. And we're going to look at them one at a time, and we're going to start by looking at the variable a. And the variable a is what's going to determine the shape of our parabola, which is what this curve is called. So let's look at the shape, since we have it nice and big on this screen. Let's look at the shape of this parabola and see if we can pick up any patterns that might help us determine what the shape should be for the other parabolas. If I start at my vertex, and if I plot those same points again, let me get them plotted. Here's one here, and then there was one here, right? And then I had -2, 4, and I had -3, 9. Those are the points that I have in my table. If I look for a relationship or a pattern from one point to the next, I see that each time I go over one space, I'm going up different amounts. So when I go over 1 and I go up 1, I get to the first point. When I go over another space and I go up 3, I get to my second point on the right side. When I go over 1 and I go up 5, I get to my third point. Now, again, this isn't just something that I'm, making up these numbers and just repeating them. This is a pattern that we see in the original graph, and by original, I mean just x squared, like nothing being multiplied, subtracted, added, anything like that. So we're going to use this pattern, this 1, 3, 5 pattern, to graph some of our other parabolas where we're changing the shape. So here's the first one is our original, and we know that we went over 1 and up 1, over 1 and up 3 to get to the next point, and then over 1 and up 5 to get to the third point. So we went over 1, up 1, over 1, up 3, over 1, up 5. That's our basic structure. So I'm going to write that in here for our second parabola, over 1, up 1, over 1, up 3, over 1, up 5. But when I look at the graph, I notice that even just to get to my first point, I have to go over 1 and up 2. So what's happening here is the distances are being scaled, which means they're getting longer by a factor of this number, which means down here I'm not going to go up 1 because my A is 2. I'm going to go up 2. And then I'm not going to go up 3 because my A is 2. I'm going to go up 6. And then this 5 is going to become a 10. I have to double everything because my A is 2. So let's see how that looks in the graph. I've already gone over 1 and up 2. Then to get to my next point, I would go over 1 and up 1, 2, 3, 4, 5, 6. That gets me to my next point. And then over 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes off my graph, but it would be somewhere up here. And because I'm still going over 1, but I'm going up larger amounts, that creates a more narrow graph. So when you see a number that's multiplied in front of the x squared, and that number is, well, we're going to see what kind of number, but we know so far that 2 gives us a more narrow graph. When we look at 3 being multiplied, this graph looks even more narrow than the last one. So I'm going to fill in our pattern of 1, 3, 5. But this time we're going to scale it by 3 because we know that everything's being multiplied by 3. So this is going to be 3, this is going to be 9, and this is going to be 15. So now let's look and see how that translates to the graph. We go over 1, up 3, over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I could, I would go over 1 more and up 15. It just doesn't fit on this graph. All right, and last one. Now our A is equal to 1/2. So I'm going to start with my same 1, 3, 5. But now I need to multiply each one of these by, you guessed it, 1/2. So that's going to be 1/2. This will be 3/2, which is 1.5. And this will be 5/2, which is 2.5. So let's see how it looks on the graph. That means I'm going to go over 1 and up 1/2, over 1 and up 1.5, over 1, up 2.5. And that's exactly what we see on the graph. So what we're doing here is we're using patterns to graph parabolas. All right, so let's look at some other values of A. Now, you might notice that these parabolas look very similar to the ones we just looked at. We have a value of -1 for A, a value of -2, -3, and -1/2. So the number part is still the same, but the difference here is that we have a negative out in front. So everything that we filled in down here is going to be the same. We're going to start with our 1, 3, 5, but because it's negative, it means that we're going down, not up. So I would show that by putting a negative in front of each of these. That means I'm going to go down 1, down 3, down 5. In the second graph, I'm multiplying everything by -2. So same thing as we had before. I cross each of these out and double. So this would be 2, 6, and 10. But since I'm going down, it would be down, down, down. Right? So the negative that's out in front tells us that the parabola is going to open down. The last 4 that we looked at were all positive. They opened up. Another observation that we can make is, although when we went from 1 to 2 to 3, we got more and more narrow. When we used a fraction coefficient, our parabola got wider than we started with. So a number that's greater than 1, again, just looking at the number, not the sign in front, but a number that's greater than 1 is going to give us a narrow parabola, whereas a number that's close to 0 or a fraction, less than 1, is going to give us a wide parabola. We see that same thing happening over here. This is going to, the negative means this is going to open down, and the 2 means it's going to be narrow. Again, here in the next one, the negative means it's going to open down. The 3 means it's going to be narrow. In the last one, the negative means it's going to open down, and the 1/2 means it's going to be wide. And we know how that looks down in our 1, 3, 5 table. So now that we've looked at A, let's move on to the next variable, which you'll see it here. The next one is inside the parentheses, and it's H. We're going to start again with our original, untouched, unchanged parabola. And we're going to, this is called the parent function, but you don't have to know that. It just means that it's the original one. And let's see what's happening here. I can see that in this graph, my vertex started here, and it shifted 1 to the right. So this -1 has resulted in a shift to the right 1. In this graph, my vertex started here, and I'm shifting 4. So this -4 resulted in a shift to the right of 4. Down at the bottom, now I'm shifting in the opposite direction. All of these graphs have shifted my original vertex to the left. So this +1 in the equation resulted in a shift to the left 1. This +3 means I shifted to the left 3. And this +4 means I shifted to the left 4. All right, so we know so far that this A is going to determine both the shape, the way that it opens, up or down. It's also going to tell me whether the graph is narrow or wide. This variable, or this value, because it's not going to be a variable, it'll be a value, this number, or whether it's -h or +h, is going to tell me whether it's going to shift right or left. So now there's just one more variable to look at, K. So again, we're starting with our original. And it looks like in both of these graphs, I have shifted my parabola up. So in this one, I added 1, and that resulted in a shift up of 1. Here I added 4, and I shifted up 4. In the bottom two, it looks like I shifted my parabola down. So here's my vertex started, right, and the original. So it shifted down 2. So this -2 ended up shifting me down 2. And this -4 shifted me down 4. So this last variable is going to tell me how many to shift up or down. All right, so let's practice it. My vertex in my original graph is going to start right here, so I'm going to just lightly draw it in. But let's go through and decode this equation before we start graphing. The negative that's out in front of the 1 tells me that my parabola is going to open down. The 1 means I'm not going to change the width. It's not going to become more narrow. It's not going to become more wide. It's just going to be as it originally was with my 1, 3, 5 pattern. The -3 tells me that I'm going to shift to the right 3. And the +1 at the end tells me I'm going to shift up 1. So let's start with the shifting to the right and up. So I'm going to take my original vertex point. I'm going to shift to the right 3. 1, 2, 3, and I'm going to shift up 1, so there's my vertex. Now I'm going to do my 1, 3, 5 pattern to get some more points. Remember, it's always over 1, and then I'm going to go up 1, up 3, up 5. So from this original point, and actually I'm not going to go up this time, I'm going to go down, so I'm going to make these negative. So from my vertex point, I'm going to go over 1, down 1, over 1, down 3, over 1, down 5. 1, 2, 3, 4, 5. I'm going to do the same thing on the other side. Because something we didn't talk about is the symmetry of these parabolas. Because they're the same on the left side and the right side, they have a line of symmetry. And for a parabola, it's called the axis of symmetry. And it's the line that would go right through the vertex, splitting the parabola into 2 equal halves. So now let's get some information written down. We have our vertex point, right? So our vertex is at, it was at 3, 1. And you can see those original values in the equation as well. Our axis of symmetry, I'm just going to put SYM to shorten it, is the vertical line that goes through that vertex. So it's x equals 3. Now we can also figure out or identify what our x and y intercepts are. My x-intercept, I have 2 of them, is where it crosses the x-axis. It would be right here at 2, 0, and right here at 5, 0. So my x-intercepts are at 2, 0, and 5, 0. And I can even see my y-intercept in this graph. My y-intercept is at 0, and then how many? 1, 2, 3, 4, 5, 6, 7, 8, negative 8. All right, let's try that again. Oh, we're done with this parabola, so let's move on to the next one. That's what I meant to say. Okay, so for the next one, remember, we're going to decode it first. The minus sign means that it's opening down. The 3 that it's being multiplied by means that this is going to be narrow. I'm going to have to scale it or multiply everything by 3. The minus 1 means I'm going to shift right 1. And the plus 3 means I'm going to shift up 3. So let's start with that shifting first. Here's where I start. I'm going to shift to the right 1 and up 1, 2, 3, and I'll land right here. And now I'm going to do my table. I have my 1, 1, 1, and 1, 3, 5. But this time my A, my value for A, is 3. Actually, it's a negative 3. So that means this is going to become a negative 3, a negative 9, a negative 15. All right, so let's start plotting some points. I'm going to start at my vertex. I'm going to go over 1, down 1, 2, 3. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to do the same thing on the other side. And that's it. I've got my parabola. The coordinates for my vertex here are 1, 3. And we could have seen that just by looking at the equation as well. And my axis of symmetry that goes down through that vertex would be x equals 1. Then I could also go through and list my x and y intercepts if I needed to. All right, next one. Let's decode first. There's no negative out in front, which means this parabola is going to open up. I am multiplying by 2, which means it's going to be narrow. I'm adding 2 inside the parentheses, which means I'm going to shift to the left 2. And I'm adding 3 at the end, which means I'm going to shift up 3. Let's start with the shift. Here's where I start at 0, 0. and I'm going to shift left 2 and up 3. 1, 2, 1, 2, 3. I'll land right there. And I know it's going to open up, so now it's time to figure out the shape of my graph. So I'm going to do my little table, my 1, 3, 5 table. This time my A is 2. So I'm going to multiply each one of these by 2. That means I'm scaling the distances by a factor of 2. And it's going to open up. So starting from my vertex, I'm going to go over 1, up 2, over 1, up 1, 2, 3, 4, 5, 6, and that's about all I'm going to be able to fit. I'll do the same thing on the other side. Draw in my curve. Write in my vertex point. My vertex is at -2, 3. And the equation for my axis of symmetry is x equals -2. All right, so when it comes to graphing these, practice makes perfect, so let's do a few more. Oh, and something to point out, on this last one that I graphed, there were no x-intercepts because our parabola opened up and the vertex was already above the x-axis.